Hello everyone, and welcome aboard. You're listening to Space Farming, where ancient Chinese agricultural wisdom meets the vast unknown of outer space. While the world dreams of rockets and Mars landings, China quietly planted a tomato in orbit, and that's just the beginning. From lettuce grown with astronaut breath to rice swaying in zero gravity, this is more than science, it's a story of culture, continuity, and cosmic cuisine. Stay with us as we explore how Earth-born farming instincts are reshaping life among the stars. This is Space Farming, brought to you by a channel dedicated to bridging China to the world, and helping you know China better.
Dear friends on Earth, this is the crew of Shenzhou. Tonight, our space dinner is freshly picked cherry tomato salad. Astronaut Wang Yaping raised a transparent container toward the camera. Water droplets rolled across the bright red fruit, while the plant cultivation pod behind her glowed in dreamy red and blue light. As this scene was broadcast live from the space station and spread across the globe, American netizens flooded the comment section. Wait, China opened a countryside farm in space before even landing on Mars? That watering can floating in zero gravity looks exactly like the one my grandma uses to water chives on her balcony. Let's rewind a few weeks aboard China's space station. When Wang Yaping snipped the first cluster of tomatoes with a custom-designed scissor, the red fruit, barely 3 centimeters in diameter, carried far more than just vitamin C. It was the first Solanaceae crop in human history to fully ripen in microgravity and be served directly at the dining table. What shocked Western counterparts even more was the cultivation pod's smart system, which was broadcasting in Mandarin. Current substrate moisture, 65%. CO2 concentration adjustment recommended for tomorrow. This system that speaks human language was quietly fulfilling a quote from Chinese leader Mao Zedong half a century ago. What's the biggest problem in the world? The problem of eating. Indeed, while Elon Musk was still grappling with rocket recovery costs, Chinese space engineers had already embedded the philosophy of food is the foundation of the people into the DNA of their space station. After all, in a country that produces 50% of the world's vegetables, even the space station's portholes resemble the balconies back home, not adorned with ornamental vines, but lined with potato seedlings that yield space tubers, and dwarf rice strains that leave NASA experts scratching their heads. To understand China's obsession with growing vegetables in space, you must first decode their farming DNA. At the Banpo archaeological site in Shaanxi, scientists unearthed millet seeds dating back 6,000 years. In the murals of Dunhuang, celestial maidens float beside mortals tilling the soil. Even in hypermodern cities like Shenzhen, rooftop community gardens are always oversubscribed. As the New Yorker once quipped, give a Chinese person a patch of cracked tile, and they'll grow scallions in the seams. Give them a space station, and they'll probably turn the entire cabin into a rotating farm. This instinct has exploded into astonishing creativity in zero gravity. In 2016, aboard the Tiangong-2 lab, astronauts Jing Haipeng and Chen Dong completed humanity's first space-grown lettuce experiment. While American scientists debated whether agriculture in space was a waste of resources, Chinese researchers, channeling the stubborn spirit of the mythical Shennong, got to work. We don't just toss seeds and hope, said Professor Wang Longji of China Agricultural University during a TED Talk, holding up a tiny glass vial. See this? It's a lettuce seed cultivated using CO2 exhaled by astronauts, wrapped in a cornstarch capsule, a space nutrient shell. It's like dressing the seed in a spacesuit. What truly stunned the West was China's vegetable diplomacy. While astronauts aboard the International Space Station still relied on dehydrated vegetables shipped from Earth, China's space station had already achieved a modest goal, harvesting fresh lettuce weekly. In 2023, when a Russian cosmonaut tasted a Chinese-grown space cucumber for the first time, he gave an enthusiastic thumbs up. This is way better than the moss we grew on Mir. If the lettuce experiment of 2016 marked the space farming 1.0 era, then by 2025, China's orbital agriculture had evolved into a full-fledged, country-style farm pro max. Let's follow the timeline of breakthroughs that left even NASA envious. When astronaut Jing Haipeng used a syringe to hydrate seeds in zero gravity, scientists at ground control were holding their breath. Don't underestimate this lettuce, recalled Dr. Luo Lixin from China Agricultural University. Its seeds went through 18 layers of quarantine, cleaner than a president's salad. To make this possible, Chinese scientists developed pelletized seed technology, transforming lettuce seeds into 5 mm spheres, like space-grade chocolate drops. These pellets prevented the seeds from floating away and slowly released nutrients over time. The cultivation substrate? A fermented straw-based, space humus that, surprisingly, gave off a faint scent of rice paddies. When Dr. Zheng Huiqiong's team began growing rice in the Tianhe core module, botanists around the world held their breath. In microgravity, rice roots drift like drunken octopuses, and leaves lose their sense of direction. But Chinese scientists developed a light magnetic coordination system, red and blue LED lights to simulate sunlight, combined with a gentle magnetic field to help plants distinguish up from down. After 120 days, golden rice stalks swayed gently in the cabin. Back on Earth, mass spectrometry revealed that the space-grown rice had 15% more starch than its terrestrial counterparts. It seems microgravity made the rice channel more energy into grain production, Dr. Zheng said with a smile. What truly stunned the world was the debut of China's extraterrestrial artificial photosynthesis system in 2025. The device, resembling a giant glowing aquarium, could convert astronauts' exhaled CO2, water recycled from urine, and solar energy into oxygen and glucose. It's like raising a colony of glowing electronic plants, said project lead Wang Longji, pointing to the nanofiber membranes inside the chamber. These synthetic chloroplasts are 3 times more efficient than real leaves. One day, on Mars, we could use the planet's CO2 to produce food and air directly. In international aerospace circles, China's space farming technology has earned a charming nickname, Cosmic Countryside Black Tech. These inventions, rooted in Eastern wisdom, have solved countless problems once deemed impossible. The biggest challenge in space farming is substrate aeration. In microgravity, a single misstep in watering can create floating water bombs that drown plant roots. Chinese scientists found inspiration in the drainage principles of Sichuan pickle jars. They invented a 3-layer breathing substrate, porous ceramic at the bottom, fermented straw in the middle, and water-retaining cotton on top. It's like building a bathroom with a floor drain for the roots, explained an expert from the Yunnan Academy of Agricultural Sciences, showing a cross-section diagram. Excess water automatically collects at the bottom and is recovered through a condensation system, 40% more water efficient than NASA's rock wool. How do you keep plants comfortable in a space cabin with 50 degrees Celsius temperature swings between day and night? Chinese engineers turned to the microclimate regulation principles of Suzhou's classical gardens. Inside the cultivation pod, they installed biomimetic leaf vein pipelines, transparent tubes that deliver nutrients and regulate temperature via capillary action. When overheated, the water inside evaporates and absorbs heat. When too cold, embedded graphene membranes emit far-infrared light, like wrapping the plants in a space electric blanket. Plants need specific wavelengths of light to grow. Traditional space stations use monotonous red-blue LEDs. Chinese scientists added a twist, disco mode. We discovered that plants require different light rhythms at different growth stages, just like humans need day and night cycles, said lighting designer Li Wei, demonstrating the spectral interface. During seedling phase, we use blue light to make them do morning exercises. During flowering, red light helps them dance the square dance. The result? Tomato ripening time shortened by 20%. Inside the exhibition hall at Jiuquan Satellite Launch Center hangs a special mural. On the left, a scene of Banpo villagers sowing millet 6,000 years ago. On the right, a vision of Chinese astronauts harvesting potatoes on Mars in 2040. In the center, a golden inscription of Mao Zedong's words. Grain in hand, peace in heart. This obsession with food security is now driving an interplanetary agricultural revolution. Launched in 2025, the Martian Farm Initiative has already completed a 3-year trial at the Qinghai Mars Simulation Base. Scientists successfully cultivated salt-tolerant, space chives, in simulated lunar soil. These slender-leafed plants can grow in oxygen levels below 1%, and they carry a natural pest-resistant trait, thanks to trace amounts of radiation-induced phytochemicals in their sap. "We're not just growing vegetables," said Professor Li Jinxiang of China Agricultural University, pointing to a tray of microwheat. This dwarf variety secretes organic acids that break down heavy metals in Martian soil. It's like giving the red planet a digestive cleanse. Even more astonishing, researchers are experimenting with spirulina cultivation using astronaut urine. This high-protein algae not only makes nutritious space biscuits, it also purifies wastewater. In the future, urine might be more valuable than gold on Mars. At the 2024 Vienna International Space Conference, an unexpected moment stole the spotlight, as the Chinese delegation presented a cold dish made from space-grown lettuce. A NASA representative discreetly pulled out a notebook to jot down the recipe. "Our astronauts have eaten dehydrated vegetables for 20 years, the NASA Food Systems Director later admitted in an interview. Seeing fresh greens made their eyes light up. This kind of culinary diplomacy is quietly reshaping the landscape of international space cooperation. In 2025, China's space station welcomed joint research teams from Brazil and Kenya. They didn't just study cultivation techniques, they left with a vegetable starter kit, miniature grow modules, resilient seed varieties, and intelligent monitoring systems. In Africa, many children don't have access to fresh vegetables, said Kenya's Minister of Agriculture, gently touching a tomato seedling. Your technology can turn deserts into gardens, just like you've done on Earth. But the deeper impact lies in the realm of culture. As Western teenagers watched live streams of Chinese astronauts gently combing the leaves of space-grown potatoes, their perception of space began to shift, from flashy rockets to the quiet dignity of sustaining life. Nature magazine captured it best. China's space farming program brings warmth to cold technology. It's like transplanting a hometown garden into the cosmos. This reverence for life may be humanity's true passport to the stars.